Hey everyone, welcome to Network Mellow. In this video we are going to talk about subnetting, one of the most important concepts in computer networking. Subnetting allows us to divide a large network into smaller subnetworks, or subnets, which makes it easier to manage and optimize our network. First, let's start with the basics. An IP address is a unique identifier assigned to each device on a network. The IP address is divided into two parts, the network ID and the host ID. The subnet mask is a 32-bit number that determines the size of the network ID and the host ID. To subnet a network, we borrow bits from the host ID portion of the IP address and use them to create a subnet ID. The subnet mask is updated to reflect the new network and host ID sizes. Each subnet can have its own range of IP addresses. Now, let's dive into some of the key benefits of subnetting. One of the main advantages of subnetting is that it improves network performance. By breaking up a large network into smaller subnets, we can reduce the amount of traffic that needs to be transmitted across the network. This helps to reduce congestion and improve response times. Another benefit of subnetting is that it enhances network security. By separating devices into different subnets, we can create barriers that help to prevent unauthorized access to our network. For example, we can create separate subnets for our servers, workstations, and guest devices. This can help to prevent a compromised guest device from accessing our critical servers. Subnetting also allows us to allocate IP addresses more efficiently. Without subnetting, a large network may have many unused IP addresses that are reserved for future growth. By subnetting, we can allocate IP addresses only to the devices that need them, which reduces waste and allows us to make better use of our address space. There are two main methods of subnetting, classful subnetting and classless subnetting. Classful subnetting is an older method that was used before the introduction of variable length subnet masks, VLSMs. Classful subnetting divides IP addresses into classes based on their first octet, with each class having a default subnet mask. However, classful subnetting is limited because it only allows for a fixed number of networks and hosts per network. Classless subnetting, on the other hand, uses variable length subnet masks, VLSMs, to allow for more flexible subnetting. With VLSMs, we can create subnets of different sizes within the same network, which allows for more efficient use of IP addresses and makes it easier to manage the network. To subnet a network using classless subnetting, we start by determining the number of bits we need to borrow from the host ID portion of the IP address to create the desired number of subnets and hosts per subnet. We then update the subnet mask to reflect the new network and host ID sizes. Each subnet can have its own range of IP addresses. For example, let's say we have a network with the IP address 192.168.1.0 and a subnet mask of 255.255.255.0. We want to create 4 subnets, each with 64 hosts. To do this, we need to borrow 2 bits from the host ID portion of the IP address, which gives us 4 subnets. The new subnet mask is 255.255.255.192. Each subnet can have its own range of IP addresses, such as 192.168.1.0/26, 192.168.1.64/26, 192.168.1.128/26. Supernetting, on the other hand, is the opposite of subnetting. Instead of dividing a network into smaller subnets, Supernetting combines several smaller networks into a larger network. Supernetting is used to reduce the routing table size in a network, making it more efficient. Subnetting divides a large network into smaller subnets while Supernetting combines smaller networks into a larger one. I hope this video helped you understand the basics of subnetting and supernetting. If you have any questions, feel free to leave them in the comments below. Thanks for watching.